Thanks, computer. All right. Okay. So this is I kind of email everybody out like, hey, how to install GDAL. So hopefully you've been able to get that installed. If not, that's fine. It's all command line. So if there's instructions for with Windows, there's instructions for Mac. But with either case, you're using it. It's all command line, and it's built using Python. So as long as you have Python running on your machine, it'll work. So to go through some of this, what I wanted to do is like kind of just walk through if as long as you have access, you should have access to these source data files in our shared folder. And then what we'll do is let me show you the Google Docs. I'm just going to share screen here. All right. Here we go. Okay. Wow, look at all that. That was fun to write. Okay. So by the way, and if you have any questions about how to set up stuff, I just had to put it in here. There's 2 sets of instructions. And yeah, this thing, by the way, if you open up terminal on a Mac and just run this whole thing in here, it does this. Oh yeah. Let me just, I'll give it to everybody in the chat here really quick. Before I forget. Hold on. Why don't you? Oh, there we go. Oh. There we go. So yeah, this is just under, in our shared folder, it's under resources. And I've been going through and documenting as the layer's been getting built, how it's being done. Yeah, so brew install GDAL. So there's this whole process where you on a Mac, if you don't have Homebrew installed, install Homebrew and then use Homebrew to install GDAL because nothing in life should ever be easy. So that's just, this is this first box here. It's just like how to get this set up. The other ones are, we're using, so this is the elevation roster. And this is, we have an elevation. So this is actually like from LiDAR data. So this is elevation across the extent for LA County. And it's a resolution, spatial resolution is 10 feet. And it's in a projection. The EPSG, by the way, is like, that's the projection, which is 2229, which is like state plane system, Southern California or whatever. And the reason I bring that up is that you want to keep that in mind that that's the projection we're going to use for all the other map layers. So everything's going to get reprojected to that. And everything is going to have a resolution of 10 feet. Even though most of the pixels, most of the other data we have is not that high, like highly resolved, we'll just divide up everything by 10-foot grids because that is the highest resolution data we have, and we'll just go with that. Because I don't want to lose resolution on our highest resolution data. And it doesn't really matter if we have data that's really coarse, but we can chop it up. So we have that. This is our, now that this is, by the way, the link to it in our shared documents. This is where the source file is. And then we have the next thing, I'm kind of running through this process, which is going to be common all the map layers. We have our city boundary layer. And what I did is I ran this command here. So this, by the way, this is the GDAL command. And I'm going to go through kind of like, what does this mean? And this, by the way, I encourage you just to try out some of these. For like, these are like the ones I've already written here are the ones like I've gotten to work. There is currently one that I am not getting to work right now. We're not going to go over that because I don't want to embarrass myself because I can't get it to work for some stupid reason. And I don't know why, because I got to work like 2 years ago. So it's really annoying me at the moment. And that is I'm trying to get the light pollution layer imported into our system. And for some reason, it is like, it does not like it. So when I get that fixed, I'll let you know. But we are going to include light pollution in our analysis. So that'll be kind of cool. It's just there's something weird going on with it. Anyway, this is the command when you open up terminal on a Mac or command CMD or whatever on a Windows machine, this is the command you run when you have GDAL installed. This whole thing here, so OGR to OGR, is a command within GDAL. And what it means, and by the way, in case you're wondering, like what, I'm going to put this in chat as well. But if you look at, if you go to gdal.org, well, I guess I don't even have to put that in chat. If you just go to gdal.org, they have like, you actually have the manual pages for every single command they do. That's not to say it's going to be terribly intuitive when you see it, but at least there is stuff written there. And let me go through and kind of parse out what all this means. So OGR to OGR is the actual command for taking a shapefile, in this case, the LA city boundaries, and reprojecting it from the coordinate system it is in. And the coordinate system it is in, I think, is just the standard like WGS84, like, which is EPSG 4326, which is just like kind of like regular like spherical map projection. And you want to reproject it to EPSG 2229, which is like Southern California state plane. And to specify that, you want to say T, this is this whole thing. This means target sort. You want to, this is for the, to target it. So -T underscore SRS, followed by the EPSG code. And this tells it, okay, reproject it to this system. And then what you do next is you say, all right, and this is kind of weird how they do this, but you put in the target file name. So you actually say like what you want to call it first, and then you put in the original file second. Why the order is flipped for this command, I don't know. I'm just letting you know that it does this for some weird reason. But this should take you, and once you have that file downloaded, make sure, by the way, you're also in the same directory as the files you're working with. By the way, please stop me if that doesn't make sense what I mean by that. Like, it's just when you open up terminal, you want to make sure you're actually in the same directory as all your files. Just, do you want me to show you what I mean by that? Okay, all right. So let me, I'm going to stop share for a second, and I'm going to, let me just, I'll just share everything. It's just easier. I'm going to be switching back and forth. Okay, so what we do is we go to terminal. All right. So in terminal or in the command or whatever, what you want to know is like, all right, am I in the same folder as all my stuff? So in Mac, which is just Unix, to be able to figure out where you are, you use the command called present working directory, which is PWD. That's all you type, and you hit enter, and it'll give you like the whole string of folders that you're in. All right. Cool. So that's the first thing you want to do, is just like, where am I? Which is, all right, in Unix, like PWD means present working directory. It just tells you where you happen to be at. Now, the next thing you want to know is like, what's in there? What's in the folder I happen to be in? And to do that, the original command is just list, which is just ls. And when you do that, it'll list everything. But it means you might be able to tell if your stuff's there. So you type in ls. Oh, God, there's so much stuff here. How am I ever going to know? Okay. So in this case, let's say we don't want to list everything. All right. We just want to list let's say we just want to list just the shape files, because we know at least we're not interested in rosters or all these other things. So if we want to just list just the shape files, what you do is ls space, and then Shift-8 gives you the wildcard or asterisk, and you do .shp. What this means is it tells you the wildcard is just like a Unix way of saying everything. Just give me everything that follows that pattern. So it just says, give me everything that is a shapefile. And then you hit enter. All right. And then there's far less here that you're actually looking at. This gives me all the shapefiles I'm dealing with. Okay. And as I can see here, oh, look, city boundaries is right there. Wow, what a day. Okay. So city boundaries is there. That means I'm in the right directory. which means that if I run this command, it'll actually know where the stuff is. It'll like you'll be able to just run it no problem, or hopefully no problem. Because if you run that command and you're not in the same directory, it'll just give you an error that says like, I have no idea what you're looking for. Okay. But these are just like with basic Unix commands. If you have any questions about it, like if you just Google like Unix command, like basic Unix commands, or if you want to go, I can go through more of them with you. But this is just stuff to help navigate when you're in command line. So right now we're in, so this is our present working directory. That present working directory happens to contain the file we want. So if we ran this command, it should work. And the command that you use in that case is to reproject stuff looks like that. Okay. And the reason why, by the way, why I'm reprojecting it is because our target, like our sort of the original files we have that have the highest spatial resolution are in this coordinate reference system. And so just out of sake of laziness, I'm just going to make everything in that same system. So I'm just going to choose, these are the highest resolution data. Everything will be aligned to it, which is really important because ultimately we're taking all these map layers and stacking them, and they have to be in the same exact format to make that work. So in order to use the LA city boundaries, I need to reproject it in order to correctly cut out stuff down the line. Okay. So the first thing, I'm going to go through this whole command here kind of part by part because it is not going to make sense. So now we're using something called GDAL warp. Okay, and let me give you I'm going to show you what this means. So this is if you actually type in Google GDAL warp, you'll get this whole command page. It looks like this. And it has got all these different parameters you can put in there. By the way, stop me if you have any questions. Like, I know this is probably, a lot of stuff is just going to look completely weird. But GDAL warp is the command that allows you to like manipulate, let's say, rosters. So it allows you to like change the projection. It allows you to like clip them out. It allows you to change the node data values, all that sort of stuff, which we are going to need to do for this project. And so just going through all this, there's all sorts of parameters here. So again, they have these like, spatial references. So like, what's the source EPSG? What's the target EPSG? So remember, like, we're always going to target, in this case, EPSG 2229. Some of these other like parameters don't ever really use much. So these ones I'm skipping through, like I've never really used for anything. So anyway, so we have this. So this is, I use this sometimes, this is -te. So set georeference extents of the output file. This is basically to say like, hey, whatever you reproject this into, what are going to be the boundaries, the geospatial boundaries, like east, west, north, south, or in this case, they go x min to x max, which is like furthest west longitude for this east longitude. And then y min to y max is south to north, is how they do it. And -te is like sort of the prefix for that. I'll show you an example of what that looks like. -tr, this is X resolution, Y resolution. This is a way of saying when you're reprojecting it, what are the pixel sizes going to be? So if you're in a system, an EPSG that deals with feet or meters, you're going to want something with X resolution, Y resolution. It's going to specify the number in meters or in feet that's the size that's your pixel size. So, which is going to be really useful for us because we have to specify all that. -TAP, target aligned pixels, is basically saying if we're going to target the center of what we're trying to cut. Like, let's say we're taking a big roster and cutting it, and we wanted to make sure that the center pixel of that roster is in the center of whatever we're cutting in, which is basically a way of forcing it to align. It'll do that. So it's a way of just like sort of forcing it to like stay centered to like whatever outline we're like cutting out of this. Some of these other ones I don't use as much. Yeah, resampling. Yeah, I haven't used resampling method yet for this project, but all right. Source no data. This is, so no data values are in your rosters when you deal with this. Like you might have dealt with this already in ArcGIS or QGIS. A lot of times you're mapping data. You may have a lot of areas on your map where you don't have any values, where you never took any measurements. So in that case, you want to specify some like just dummy number that you call no data, because you can't just put in a numerical roster no data. You have to give it some like number that's never normally going to come up. So for example, like -9999 or something like that, a lot of times people throw that in as a no data. In our case, we're using -32,768. The reason being, again, is the no data value for our original like highest resolution rosters are that. But a lot of different rosters have different no datas. And then we want to standardize it so that we can then reproject it and say like what the destination no data value is, so that we can convert what the no data is, so that all the numerical, the sort of the dummy numbers that we use for no data are the same. Don't worry, I'm going to go through this. Let's see a bunch of other stuff here. OF format. It's just like if you want to deal with like large, sometimes if you're dealing with really large rosters, you might need to specify this. Same with like .co is dealing with data types. This one that's really important is called cut line. This is if you want to take your roster and when you reproject it, you want to cut like to a city, like let's say a boundary. In our case, it'd be the LA city boundary, because a lot of our data is going to be like, let's say the size of LA County or bigger, and we don't want it. So we just want to clip out that area. You can say specify cut line and then put the name of the shape file for your boundary. And that'll clip it. All right. And then, yeah, crop to cut line. All right. And then source file, destination file. Basically, what's the input roster? What do you want to name the output roster? Okay. That being said, oh, somebody highlighted this. Wonderful. Okay. So that being said, let's go through what all this means. So we have GDAL warp. All right, we're using that command. Our target projection is our Southern California state plane. I'm putting in this like WM 2048 thing, multi-thread -WO. This is basically saying like, I'm trying to deal with really, really large data right now. And these prefixes you can put in there and it'll help you to essentially split up the roster into smaller chunks in the computer, and it'll like deal with them separately in parallel. So you can include those in all of these if you want. You don't necessarily always need to. So when you say like do all that and they say num threads equals all CPUs, it's basically saying each one of the cores in your computer are going to like be running this simultaneously. So most of your computers probably have like 4 or 8 cores or something like that. So it'll speed up the process. -co block size equals 512 is basically specifying how big in kilobytes for each chunk of that map you want to like section out when you're processing it. And yeah, so it's saying -co tiled. Tiled means again like split it up, and then when you're done reprocessing it, stitch it back together. -co is again another prefix saying like big TIFF. Big TIFF is just another way of saying like I'm dealing with a really, really big file. Okay. You can run this for all of them if you want, even if it's not a big TIFF. It might just give you a warning saying like that you don't really need to do this, but for the elevation data, it's a lot of information, and so it is a big TIFF. -co compress equals LZW. This is something else you might want to include on all your commands for dealing with rosters. Compress LZW is a type of file compression. Basically, it's there so that when you do all these operations and you output it, you don't end up with like a map layer that's like 20 gigs in size. You'll end up with something that's like 200 megabytes. If for whatever weird reason, like a lot of these conversions, if you don't specify that, the output file size is like enormous, and it doesn't need to be. And I've learned this the hard way. By the way, this is all written in this file here for a reason. Like, basically, if you want to try to copy pasta this and like for different layers of your building and just to test it out and seeing if it works. That's kind of why I've been putting this in here. Source no data. Okay, which is in our case, this elevation roster, the source no data is just this like really long string of numbers. Why? I don't know. I didn't make it. But our destination no data, and this is going to be what we're going to reproject everything into, it's just going to be this, because we just want to all to match. Now I want to assign target align pixel, basically means I want to make sure it's centered on the LA city boundaries. Dash TR 1010 means the pixels are going to be 10 feet across. Cut line is our boundary, is our city boundary shapefile. We want to crop it. And that means that our input layer, which we just called elevation 1, we're going to output it and just call it elevation. So if you run this whole command on your computer, as long as you're within the directory, this should work. Now, you might be wondering, how the hell am I supposed to know what source no data is? Okay, here's a command that's really useful for kind of peeling apart like what's going on in your map layers. And again, don't hesitate, like in a couple of days, if you try doing this and you go like, I have no idea, I don't remember any of this, just bug me. We'll go over it. But the way you figure out things like what coordinate system you're in, what your resolution is, what your node data values are, there is a GDAL command to do that. And it looks like this. It is just GDAL info. And if you just do GDAL info and then the roster file name you want to look at. In our case, let's do elevation 1, which is the one in this example. So elevation1.tiff, and we hit enter. All this stuff kind of comes out. Wow, look at that. Okay. So we have all this sort of stuff here. It gives us the following information. It's a driver, it's a geotiff, okay, which is kind of what I figure. File name, the size in pixels, how wide it is, how tall it is. Coordinate system, and it gives you the sort of the English name for it, which is North American data 1983, state plane California 5, and it's in feet. And then it gives you all this other like datum and all this sort of other stuff. If you want to know what the coordinate system is, your EPSG, it's all the way down here at authority, this last one, EPSG 2229. That's where it's at. And it'll give you in this system, and by the way, this system, this might sound familiar if you've done ArcGIS or QGIS. This is an easting northing system. So it's not a latitude longitude system. So latitude longitude is like degrees latitude, degrees longitude. An easting northing system is like one of those things where like you have a reference point on the Earth. You flatten out a small chunk of the Earth for your map, and then it's just literally how many feet north and east, or how many meters northeast of that pixel is where you're looking at. So that's what an easting northing system is. So that's why it'll give you this thing where it says origin. So like of your map, like what is the centroid pixel and why it looks like this. It's, some like 6 million blah, blah, blah. Because it's not latitude, longitude. It is literally like how many feet north and east of some point on Earth. So anyway, and then the pixel size 10, negative 10. I don't know why it's done this way, but like generally we were doing like square pixels. Like if you do like, it's just some like number, negative number. I don't know why it's done that way. It just heads up. That's how it always outputs it. But this is basically saying it's 10 foot pixels, which is this 10, negative 10. Okay. It'll give you the corner coordinates. So like what your extent is. So X-min, X-max. So your upper left is going to be your upper left is going to correspond to your coordinate, which is your X-min, Y-max, basically. Oh, someone's messaging me. How do you know it's feet? Oh, good question. So we went back here, the projection, this. But like I said, this was so insanely painful to learn because I didn't learn it in a class. So if I can save you any time, it'll be an achievement. But that's how you do it. You look up this information. This one's in feet. I don't know. So there are ones that there's like there's another one that's like literally the exact same except it's in meters. And unfortunately, because like a lot of this data that I'm getting from the county, because it's the United States, is in feet. So gotta live with that. I don't know. All right. So we have all this. There's other statistics here. So we have like band one. By the way, you might have what's known as a multi-band roster. So you'll have more than band one. And most of our data we're going to look at, it's just going to be one band. So it'll be band one. It'll give you the minimum pixel value. By the way, this is an elevation roster. So this is negative 190 feet. Then it gives you the maximum, which is over 7,000 feet. Min max, it gives you the mean elevation. So the mean elevation for this elevation roster is about 1,200 feet. Gives you a standard deviation. And it gives you the no data value. This is where I get that from. So I just looked that up and I just copy and pasted. Okay. And it gives you all these other like pixel statistics. But this is all stuff you can look up using the GDAL info command, which is useful. Like in order to warp things, reproject them, you do have to look this stuff up. And this is how you look it up. And this works for rosters. It does not work for shapefiles. Shapefiles, it's a different command. So shapefiles, it's like OGR info will give you OGR info is like for shapefiles. So let's see boundaries, and it'll tell you yeah, there's something else you have to type in there. I think it's no. What was it? Hold on. OGR info. It is. Let me see if I just get this to work really quick. Oh, oops. Oh my God, come on. All right, never mind. I can bother with that later. But anyway, the more important stuff is looking at the rosters. So that's how you look up basic information about the rosters. Sort of some like basic commands like how you cut or reproject or change in their data values, which is mostly like a lot of what we're doing. So this is how to like I got the elevation data, which is from the Michelle sent me from the county. And it was how I was able to take it from something the size of the county and then clip it down to something the size of LA City. So yeah. Yeah, so we use GDAL info to get the central pixel coordinate. Every other roster is going to be aligned to this point. And again, the way we know what this, oh yeah, what's up, Laura?
I was just wondering like why you wouldn't want to do this in like QGIS or ArcMaps. Like, is it too big or?
For some, well, I've gotten that, like, I think I've been able to get stuff like, I can do some of this stuff in QGIS, and sometimes you can get it to work in QGIS, but sometimes for whatever reason, like, I've just got it to hang. I don't know why. So as long as you can make sure, and if you were to like, let's say you use ArcGIS and try to standardize the maps and like make sure everything's clipped to LA, it should work. I've just, for whatever reason, like a lot of times in my experience, I can't get either ArcGIS or QGIS to take care of like all the specifications. Like for example, it'll like clip to LA but it won't like change no data values, or it'll like reproject it, but like it'll shift it like over somehow. And that might just be something weird about like how I'm doing with QGIS. But if you're more experienced with like ArcGIS or QGIS and you can get it to work, just let me know. I'm not saying this is the only way to do it. I do know that part of the reason I also use this tool is because ArcGIS and QGIS I can't run on a remote machine. And when you are dealing with big data, so with really big files, you're stuck using your own computer. And a lot of times, like I can't like if I need like 100 or 200 gig of RAM or something like that to do some of these things, like I can't run it on a machine; it won't work. So I use GDAL a lot because I can run it on a remote machine, which I have access to that. Um, but like yeah, so if you have like a lot of experience doing this in Arc and you can get it to work, great. Um, I just I don't know. It just hasn't usually been an option for me. I don't know. Is that a disappointing answer?
No, no, that was good.
No.
I was just wondering because I was like thinking about how I feel like I've done very similar stuff. The only thing that I haven't done is the changing the no data number, but
Yeah, it's for some stuff like it's fine, and I can get it to like I can get it to work. I think it's just more of just the size of the files, and it's just how much your computer can hold in memory while it's trying to do this.
mm,
Um, so I don't know. There's just sometimes there's really weird things that go on where it's just like where I just feel like I'm telling QJS to do literally the exact same thing as GDAL, and for some reason it doesn't quite work, and I've never really quite figured out why.
mm.
Um, so, someone's messaging me. There we go. Oh, Valerie's done some of this in R. Yes, I've done some of the stuff in R as well. Kind of for the same reason. Um, so R deals a lot with rosters. I don't know. I haven't done like so. I've done an R for some stuff. I don't know. I think you could do what I think all the stuff I'm talking about right now. You could just do all of it in R as well. I've done a lot of these things in R. Um, I don't know. I mean, it's sort of like a lot of this stuff. Like we don't necessarily fundamentally need to use R to do this project. I just happen to fall into doing a lot of this modeling in R. You know, for example, we wanted to do everything in Python. Probably could get away with it. So, by the way, the fact that you're bringing up like, can we do this in another tool? And the answer is usually yes. Um, but I don't know. I'm not going to be very dogmatic about this at all. It's just that whatever method you want to use, though, please document how you did it. And one of the reasons why, one is also for troubleshooting, because if stuff kind of falls apart, we can go back and try to figure out like what might have happened. But the other thing too is like think about this when we're starting to write paper and we start talking about methods. You want to document how you did stuff. So when you write in the methods, you can say this is what you did. Um, and because you're not going to like it'll be one of these things where like, you'll figure out how to do it, but you need to write it down because otherwise you will forget it in like a few days, especially for something like that gets this complicated. Um, so like I said, I'm not like if you want to use other methods, great. Just please write down how you did it though. Like that's all I'm saying. Kind of like so what I did here. I did this partly for my own sake, just because I'm not going to remember off the top of my head these commands. But also just so like because you can look at it and go like, oh, okay. So that when you try to build some of your own roster layers for this project, you can just kind of look at it and go like, sort of copy pasta. So, but anyway, this is like a lot of this sort of with the example I ran through. Like, see if you can get it to run on your own machines. Because these are all these layers here we've been able to build, so they should work. That's why I wanted to include it in the document. There are other ones that I'm kind of still working around with, and then I know that we have started to get now. So Jose sent me some documents that show the attribute tables for some of the shapefile layers that we're going to rasterize. So, which has been really great, by the way. But we'll need to go through some of those and make decisions about what kind of rosters do we want to burn from those shapefiles, because those shapefiles have attribute tables that are like, I think for the EPA one, it's like 72 attributes. We're not going to burn 72 attributes. We might burn 8 of them. And then, so then the question's gonna be like, all right, well, we just need to make sure how we document it. And then we'll just create all these rosters and then just kind of throw it into the stack. Which we have 8 layers right now in the stack. So anyway. All right. So any thoughts at this point with this stuff? No. Please don't be despondent. I know this does not look very intuitive. It's just, all right. This is very new. Yeah. Actually, Valerie, what did you do in R specifically with this sort of stuff?
I'm trying to remember. It's because I took a class. I think most of us were required to take it. It was Environment 175.
Okay.
Where we played a lot with like city layers, like from the city of LA or like California.
Yeah.
And we had to convert them and then add attributes and stuff.
Oh, you did that all in R? Oh, okay. Yeah. For R, I'm trying to think what I've done with this. I mean, for R right now with rosters, I've mostly just been using to do like all the making roster stacks. But and there are ways of reprojecting things in R. The part of the reason I haven't gone through that recently is I actually started playing around with that about a month ago, and R updated how they do it, and it doesn't seem to. I don't know. Like it seems like they broke something, and I can't get it to work now. And it's like, I don't want to mess with it because I know like this will work. Like R updated something about like like spatial package and roster package, and like I don't know what they did to it. So it might just be like one of these things where I'm like, oh, it just totally works. It's just like but they changed how they did it, so I haven't quite figured out how they did it. Like I said, I think all the stuff we could technically do in R, I don't. So, I mean, unfortunately, for better or worse, a lot of this you might end up learning like how I do stuff, which isn't necessarily my goal, but I mean, there's a bunch of different ways to do this, and this is kind of the way I've started to figure out how to do it. But would be really excited if someone else here figures a different way that might actually be better. So, because this is not something I was formally trained in by any means. So, but anyway, I just the layers that the 8 layers I built. This is kind of how I did with all of them. So this is slope, which is basically the exact same process as elevation. Same with aspect, which is just like, by the way, like where it's tilted to face the sun, essentially. Like those 3 are identical. The habitat quality one is what I ended up doing. This is actually I did multiple steps. So habitat quality, that's the that's actually the layer that like Nee made that like fancy map for. Is we're taking that, and then those have a spatial resolution of 30 feet. So what we ended up doing first is convert the no data values, and then once we convert the no data values, then I just did this whole thing with like cutting, so clipping that whole map, which is like LA County basically, clip it to the LA city boundaries, reproject it, align it to the city boundaries, and then split it to 10-foot pixels. So again, like, oh, oops. So no, Nee used she actually made the original map, I think either in ArcGIS and then edited. Oh, QGIS, okay. Yeah. Oh, okay, Stevie, this is a really good question. GDAL is not for visualizations at all. Which
So you
yeah.
can't like produce anything visual out of it, like code something visual?
You can, oh, okay. It's to well you can create things you can visualize, because think about like if you have like your source roster and your output roster that you produce in GDAL, but you can't like look at them in GDAL. You can open them up in like ArcGIS or QGIS or R. But like what all like literally GDAL is, it's like sort of like this low level thing where it's like manipulating the maps and it's doing it really rapidly. But then to actually like look at it and change color schema and like all this other stuff, that's what like QGIS is for. I mean, QGIS and ArcGIS obviously they do computational things. I've just run into like these bottlenecks with like how quickly they can do it or like how well they can handle it. And then for really big stuff, like I can't use it at all because like basically I have to run this on a remote machine. So I don't think any of these layers I had to run remotely, but even still, they run a lot faster using GDAL. I think it's just because ArcGIS and QGIS have a lot of other things they have to run as part of the program, and this is just like, it's all command line. So yeah, but yeah, Nee actually made the maps and like then edited them in. Nee, correct me if I'm wrong, did you use Photoshop or Illustrator or something after that?
I actually just used the map planning thing that they had in there. Like there's a way for you to just like make it from there.
Oh, okay. Got it. All right. Anyway, so that's how I did habitat quality. And hopefully like I have these instructions how we did this are detailed enough that you can kind of go with it, because like again, like it's just, you want to kind of play around with it as you do this. And then once you get something, once you actually any of the map layers, whatever you build, just like let me know when you build it, because then I can test it out. And then literally how I'm going to test it out is I'm going to download it on my machine and then try to input it in the model and basically see if my code goes like, yes, it aligns. And if it doesn't, I'm going to like, okay, it didn't work. And by the way, we'll probably find a lot of times it won't work, and it's just frustrating, and that's just the way it is. But yeah, at least just as you do stuff, just like add it to this document, just so I know, like, so we have a record of like how we did it. Because I am currently going through notes like this for another project that I wrote like 2 years ago. All right, land use. Let's see. Okay, here we go. So some of these things I actually have in the commands. I had to use a combination of QGIS and GDAL. Because GDAL does a lot of things, but it does not, there's certain things like, I don't think it really does it all or very well. And this is where QGIS or ArcGIS are useful. But for example, with land use, there's this whole thing here. So I got this is the like land use categories. We have what you can do is we have the source, okay, we have the projection, we have the attribute layer. So when you open up the attribute tables and you get like, it's a whole like spreadsheet basically. When you're making a roster, you can only burn really one attribute at a time. And so in QGIS, one of the things I had to do, and this is kind of convoluted, but you're going to get attributes that you want to burn, but let's say they're text. So like, let's say, it's some category where it's like land use type, where it's like heavily urbanized, lightly urbanized, or whatever. You can't burn a string to a pixel. So you have to convert it to some sort of number. Even though the number itself doesn't mean anything, it's just a number to categorize it. And so that's what this sort of stuff is used for. So you go to vector analysis, you can go to do this thing where you say list unique values. And then this is this whole process I did to like basically make a number corresponding to each land use category. And then what you do is you can do this whole thing where you save that as a file, and then you go back into QGIS in the field attribute calculator, where you can do is essentially then just like input that back in. So you just like take that and you merge those like numbers that correspond to each land use category, you merge that back into your attribute table, and then you can burn those numbers into that new roster. So anyway, that's, so some of the stuff I do use a lot of, I will use QGIS. Because there's some things like, for whatever reason, like just GDAL doesn't do it. So, and again, hopefully this is detailed enough. But if you try to follow these instructions and it doesn't make any sense, let me know. So going through all that with GDAL, and then I can make the roster. The GDAL command with this is a little different. This is actually, there's a command, once you have a shapefile, you want to like burn values, there's a thing called GDAL rasterize. And in that case, you do -A, the name of the attribute that you want to burn. In this case, this is category _1. You specify the no data, specify the projection, the line pixels, the pixel size, and then -L, which is the layer name, which is in this case is the name of your shapefile, that layer, and then the name of the shapefile, and then the name of the output roster TIFF. So, by the way, all these commands, if you Google GDAL rasterize, that'll pop up as well. These are all part of like GDAL when you install it. And then I clip that. All right. Anyway, that one was probably the most involved because I had to go through a bunch of stuff in QGIS and then go back to GDAL. Yeah. But same thing with, yeah, I had to do that with flood risk. Anyway, I think the commands I have for QGIS are going to be pretty familiar. If you use ArcGIS, they're really similar commands. So anyway, this one thing you might not have if you have GDAL, you might not have this plugin. It's called MMQGIS. You might, if you want to do any of this in QGIS, you want to install that plugin. This allows you to do things like combine CSV files like spreadsheets to attribute tables for other things, amongst other calculations. So that's a plugin that you can install in QGIS. I don't know what versions of QGIS you have. I happen to have 3, 4, but all right. Ugh, look at all this. I don't know. I'm getting tired of looking at this. So hopefully this is a good enough intro. I don't like, we can wrap this up because I'm going to start up with talking about R in about 10 minutes, but any questions on this is going through this document? Yeah, what's up, Laura?
I was just wondering, and this is probably a dumb question, but where are the other layers right now that like need to be worked on? Like you probably said this a bunch of times.
No. This is a great question. So we have in our shared folder, if we go to sources and, you know what? I don't remember sharing the screen. All right, so shared drives. All right, so we go to resources, and then just under resources, new JS data. It's all under here.
Okay, so then we can go on that file and see which ones you've already done.
Oh, okay. So these, yeah.
Or,
so these are all. Oh, okay. So, and then if we, okay. Second. So if I do, so under resources, I just want to go through. So the map layer processing. Hold on a second. Where did, okay. So the map layer processing document, which is, oh, I'm gonna click on that. The map layer processing document, which is what we're looking at. And we have, like if you actually scroll all the way down, I actually have a link to it. Where we have this master spreadsheet that we made, which is, and in here we go like, it's LA segmentation map layers. And we open up that, it's all this stuff here. So like map layer name, where the source data is located, and then some other stuff like that. And again, if you have any questions about like, hey, did we already make this, or we need help still making it, just email me. It's fine.
Okay, because I was interested in just like trying it in ArcMaps and like seeing how that goes, like looking at one of those and kind of just like going through the steps that you did, but in Arc.
Yeah, that's
just to
fine.
see if my computer just totally dies or not. Who knows?
I mean, it might work. I just don't even
It
have
might.
Arc. I don't even have ArcMap. So remember, that's the other reason. So
For sure.
yeah. All right, cool. Let me stop share here. Whew. Oh, would you recommend us try it out with a new layer or layer that's just been done? So the first time you do it, try to just do it with a layer that's already been done, just because the ones I've done, it's like I know those work. So if you just do that at least for the first time, just make sure it works. And then we can start talking about like building more layers. But just try to do it with like one of the ones we already built the first time. All right, let me stop recording.